Apache Kafka has become the most popular open source solution for persistent replicated messaging in the Hadoop ecosystem. But some software engineers who are working with big data don't want to deal with the configuration and setup of Kafka. One way to sidestep this is to go with a managed solution, like Microsoft Azure Event Hubs. Dan Rosanova is today's guest, and he joins us to discuss persistent replicated messaging and the features that Azure Event Hubs provides and how that compares to how you might use Kafka. This is an interesting discussion about distributed PubSub messaging, and we also get into a great conversation about platform as a service versus open source software, as well as the future of cloud software and how that impacts software engineers. Before we get to that episode, I do want to mention that Software Weekly is a newsletter that we put out every Sunday evening to condense what happened in the world of software over the previous week. And you can sign up for Software Weekly or join our Slack community at softwareengineeringdaily.com. And we're also looking for sponsors. If you're interested in advertising on Software Engineering Daily, or if you want to try to hire through the show, send me a message at softwareengineeringdaily@gmail.com. After a quick message from today's sponsor, we will get to this episode, Event Hubs with Dan Rosanova. Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/SEDaily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's set it and forget it investment automation. Check out wealthfront.com/SEDaily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/SEDaily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. Dan Rosanova is a principal program manager at Microsoft, where he works on Azure Event Hubs. Dan, welcome to Software Engineering Daily.
Thank you.
What is an event hub?
This is a very good question. So it's a high-scale, durable, distributed buffer. Basically, the way you could think about it is almost like a logging system like Kafka, but purely as a service rather than as infrastructure.
And so what are some examples of events that would be handled by an event hub?
We get two very large categories. They're both telemetry-based. The first tends to be application events, so things like the health of a specific application, especially for large or distributed applications, like one of our biggest customers who's the Halo 5 game. They do all of the Halo 5 gaming logs through event hubs. So all the Xbox consoles are creating telemetry and pushing it into the cloud, and it's flying through event hubs. The other big category is sort of IoT focused, and that would be much more applications focused on physical things, sort of devices creating telemetry, rather than sort of software quality. It would be physical characteristics that the devices are experiencing.
Can you define that term telemetry?
Sure. So telemetry would really be instrumentation or logging, and in the case of games or applications, it tends to be more sort of like the log4net type stuff you would see, the diagnostics logs you would put into your programs. But for IoT, it really tends to be measurements of physical characteristics of environment, so things like temperature or voltage coming from solar, things like that.
Okay, so an event hub sits between publishers and consumers and acts as a message broker or a buffer, like you described it. Why is it useful to have this software layer that manages events?
Well, one of the most useful reasons is because of you actually don't want a direct dependency between your publisher and your subscriber or producer and consumer, because they will have to be matched scale and speed wise, which can be very hard to do. So that's one aspect, is you're getting some safety and decoupling there. And the other is that you may want to read events more than once, and that's a very common pattern for us. Is we see people put a lot of telemetry data into an event hub, and the average is actually 3.2 times, I think, that they read. And that's because the events, unlike a messaging system, don't get dequeued and go away. It's really a client-side cursor, so you can have different processes reading the events and doing different things with them. So, for instance, you could have a high-speed pipeline, which might be doing anomaly detection or alerts, and you could have a slower speed pipeline, which would be doing batch processing or archive, something that's less latency sensitive. And that way you can, kind of tune the characteristics both of what you're doing and what you're paying to get it done.
Could you give a canonical example of like a publisher and a consumer, or a publisher and a set of consumers that would want to consume that same type of publisher data from an event hub?
Absolutely. Going back to Halo, they read their data 3 times, and the first time is high-speed events. This is usually things like player matching. The second time is for purely just telemetry-based, and they like archive-based, and they want to save everything forever because that's how they do diagnostics over like gameplay experiences and what characters people liked, engagement sort of metrics, slow-moving data, I guess you would call that. And the last time, I'm not 100% sure what they do with it, but I can see that they read it a third time. So they're really categorizing, rather than making a universal dispatcher, which reads the stream and does everything. They're breaking out their processing into separate readers so that they can each function at a speed that's appropriate for them without creating back pressure. Because of one, it takes a longer time to process than the other.
Could you define the term consumer group in this context?
You bet. A consumer group is a construct that we created to wrap the set of partitions that you read from. It's almost like a pass-through view on a table, and it's really there for management of being able to segment off your readers from each other. Again, because this is a client-side cursor-based system, if all of your readers are reading from the same consumer group or from the same pool, it's sort of hard to see who's keeping up and who's falling behind. So this way, the consumer group construct will do things like keep the reads separate, keep the telemetry on the reads separate, so you can see that if you had 3 applications reading, you can see one of them, if it's falling behind, you can tell which one it is. Whereas if you just have a big open pool, it's very hard to see what's happening. You could actually get good aggregate performance and very bad individual performance without this concept. So it's really just an isolation mechanism for the readers.
Okay, and zooming out on how this looks from a higher level, event hubs provide this message streaming through the partitioned consumer pattern. Can you describe this pattern?
Yes, partitioned consumer, you could almost think of it, it's a sharding-based system, really. Like everything that really scales big, it's all shard-based. And each partition you can think of as a shard. And within that shard, you've got a little universe of data that's all by itself and really not dependent on the other shards in the system. And the readers just read from one of those partitions at a time, so one of those shards. So it helps for scale out. It's the core of our scale out model for both us internally and for customers using our service, in that they're able to scale to the degree of the number of partitions they have. So if you have a very, very high scale need, you'll probably need more partitions. And that's not the only driver there. Sometimes the limit is pure network and throughput, and sometimes the limit is how fast can your consumers or your readers actually process the data they're receiving. Some readers want to do things like batching or very heavy mathematical calculations that will introduce latency and stress, and they may not be able to do that much parallel work, in which case you'll need more partitions even without having a very large number or a large throughput of data. So partitions are really focused about downstream consumption patterns and less than about what's happening inside the event hub itself.
So we've done several shows about Apache Kafka, and you mentioned earlier that there are some similarities between event hubs and Kafka. What are those similarities?
Yeah, there are a lot of similarities. We love Kafka. The similarities would be that something like a topic for Kafka is pretty much going to be an event hub. In event hubs, they are both partitioned consumers. They both have a durable model, although in event hubs it's a strongly durable model. You don't get to relax it at all. They both provide similar constructs for this partitioning concept. And then sort of most importantly, I think, there are two platforms made for tremendous scale and throughput that both chose not to use HTTP as a protocol for very similar reasons. So I think that's an interesting sort of thing to bring up from the similarity side. I think anyone who's comfortable using Kafka is going to be very comfortable using event hubs. So conceptually, they're very, very similar.
What are the kinds of problems that existed with message buses before Kafka and event hubs?
The biggest single problem really focused around scale, and different messaging platforms tried to solve this different ways. For most of Microsoft's messaging platforms, we've always favored a guaranteed durability model, and that means that you're going to have a pretty slow response to ingress and egress, because you have to really do transactional based behavior. Other platforms like RabbitMQ and Tibco chose to free that up by having a memory-only based model, even if they do some in-memory replication between nodes. But what you get there is an opportunity to actually lose data. And furthermore, it's still a sort of a PubSub or a message and ACK type system. So for every message that goes in, you read it out and you acknowledge the message and delete it when you read it. So this is the core competing consumer piece that comes into play that limits all messaging platforms, especially ones that need some sort of durability guarantee. Because sooner or later, what you're talking about, whether you're using a database or a file or anything else, is really contention for a latch or a lock. And that amount of contention, no matter how hard you try, in a single lock system is going to have a finite limit. And it doesn't matter what that system is. And the brilliant thing that Kafka did to get around that was to stop focusing on tuning the lock and to start focusing on having many locks on many resources, so that it's not competing for one object or one resource. It's really much more spread out than that.
So what kinds of messaging semantics are guaranteed by an event hub or perhaps Kafka? Does this model provide any new messaging semantics?
From a new standpoint, not necessarily. There's some familiar ones. So you're going to get something like at least once delivery. In an event hub, you will get guaranteed persistence. So by the time when you send a message in, if it's HTTP, you get your 200 OK, it's already been triple replicated. It's safe inside. Even if we have a very bad crash or catastrophic failure, your data is still there. The one semantic that's a little bit different, and it can be very kind of tough to get around at first coming from a messaging standpoint, is that you don't acknowledge individual messages. So you don't delete messages. It's a time retention buffer, and the retention age is off in large groups. So it's a much more stream-focused or coarse-grained approach to messaging. And rather than focusing on reading each and every individual event, the focus is really on read a stream of a whole bunch of events. And have a lot of readers for each partition or shard in that stream. So it's a little bit different. Both systems say they do PubSub, which is technically kind of true, but if you're used to like filters and routing, that's not the type of messaging that we're talking about here.
So we've been talking about this persistent replicated messaging pattern, and I want to go into these two adjectives that are used to describe the messaging. So first, persistence. What is the persistence model for a persistent replicated messaging system like event hubs?
For ours, it's through blob storage. So we're persisting all events through blob storage, through something we've written on top of blob storage, which is kind of like not quite a database, but a similar sort of log structure that is imposed on top of blob.
Okay, and what about the replication model?
And that's actually something we get for free from using Blob, because Blob does not have Azure Blob Storage does not have an option to not replicate data locally. So within a specific DC, or region, I guess you would say. Everything in Blob is triple replicated within the data center that data exists. So this is we're building on some work of others here. It actually gives us a lot for free or for a low cost, and it's a very big challenge that is hard for platforms to solve, and is challenging for Kafka to solve as well, because there's a loss window involved if you don't have this provided on the platform that you're running on. So there are ways to provide this through hardware, like RAID, and then there are ways to provide this through services like blob storage, and we're going with a service approach.
You mentioned this triple replication across a data center. Is there any fault tolerance for data center failure?
Well, only within regions, but not between regions at this time. And it's something we've looked at. But when you start to look at the sort of scale we're doing, and right now we're running at about the 3 million requests per second range, and we have individual customers who peak above 1 million requests per second. When you're talking at that scale, and especially since we're talking sub-second processing, replication between regions becomes very, very cost prohibitive, especially if you want to have consistency. A lot of that comes down to order. So it's very hard to have order replicated live between regions very quickly. And until we get some sort of quantum networking capability, that's going to continue to be a direct function of the speed of light and a very, very taxing sort of thing. So we could improve that, but we would lose latency in the process.
Could you do like some periodic snapshot of the event hub and then like ship it to another data center or something like that? Or would that be useful?
Yeah, it's one of the things we're kind of looking at. It's something we do enable for our customers right now. This is actually a pretty fairly usage pattern. Is people will read from their stream and have a fast reader that's just writing to another region. And that way, if they have a catastrophic failure, they might be a few seconds behind, but that's all they're talking about losing is a few seconds of data.
Right.
Alternatively, another model is to publish to two places at once, either both together, which if you do, you'll have all your data, but it will be in different orders in the two regions, which can be problematic for certain use cases, or to have your senders be aware of a backup region so that if they cannot reach to one, they can go to another.
So you talked about ordering. To what degree do Kafka and Event Hubs guarantee ordered delivery?
Yes. So for Event Hubs, there's very strong. We have a little knob you can turn on it, basically, which is a very strong guarantee, and that comes with a cost, meaning an availability cost. And basically, the default is that we're not going to guarantee order, and we're going to spread messages across all the partitions or shards in the system for your Event Hub. So this way, you get the best availability because if anything's happening to one specific server in the link or one specific piece of storage, we'll skip it and just go to the next one. Whereas if you choose to use ordering, and there are two ways to do that, either with a partition key, which is just a value we're going to hash to get a specific partition number, or you can actually send directly to a specific partition, which is something we discourage people from doing, but there are valid reasons very rarely to do it. Either of those, you're taking an actual availability dependency on some server that's owning that partition. And we need to have one server owning that partition because we're guaranteeing order so that events will be saved in the order in which they were sent. So you need an arbiter of order, and by definition, there needs to be only one there. It's kind of the Highlander thing there.
So the producers will write events to the Event Hubs, and consumers can read from the Event Hubs. When does the Event Hub garbage collect messages?
This is a great question, and something I've been realizing our documentation is not very good at describing. It's actually the first question I get from everyone. So we do this basically on blocks of data that are 32 megs in size. At least right now, that's the number we've chosen. So each partition, we're filling up a 32 meg block. When that block is full, we'll seal it off and put a date on it, and then we'll start looking at it every so many hours. And the default right now is 24 hours. And any blocks that are full that have a date over 24 hours will then be deleted. The customer can choose to change that to a higher number. I think 7 days is our public highest limit. And we'll just do the garbage collection then. But the important thing to know is that we won't garbage collect until each of those blocks has 32 megabytes in it. So if you create an event hub with a whole lot of partitions and you're sending very, very small messages, then it's going to take a long, long time to fill each of those up.
So how do event hubs differ from Kafka?
Yeah, the biggest way that they differ would be the biggest, most immediate way is that event hubs are a service and Kafka is software. So when you use an event hub, there's a team from Microsoft monitoring the health for it. Everything's being looked at. Everything is being monitored. Health of the machines, not just at the operating system and network level, but actually health of the software itself. So memory pressure, CPU pressure, things like that, and throughput on the software. These things you get for free by using a PaaS type service, whereas if you use a software that you need to install and configure, they're your responsibility to make sure that everything's running right. One of the biggest differences once you get past the just software that you must run versus a service that you use is that the load balancing in Kafka is very manual. So when you create a topic, you need to figure out where the shards are going to live, like which machines. And then over time, as the load changes on your topics, you need to move load around on the individual servers. You do get some high availability from the fact that the load will move on its own in failovers, but it's not like load balancing. It's really just load sort of failover redistribution. And we have load balancing in our platform, so that's something we kind of throw on for, to make our lives easier and to make our customer experience a little bit more smooth over time.
So I want to get into the PaaS versus software discussion, but one more question about the just differences between Kafka and the underlying software of event hubs. So Kafka uses HTTP, or clients for Kafka use HTTP. Event hubs use AMQP, and I didn't know anything about this protocol before I started doing the outline for this show. So what is the impact of this difference of protocols?
Yeah, and actually the native protocol for Kafka is not HTTP. It is a proprietary protocol that's just written for Kafka. And the reason they made this decision is the same reason we did, which is that HTTP has some very high-level constructs around request response. And so it sort of limits what parts of the TCP IP stack you're able to use for things like flow control or retransmission. And these are shortcomings that are pretty bad when you get to a very high-scaled system. So our choice to go with AMQP, which is the Advanced Message Queuing Protocol, is largely based on the fact that we use that for our other messaging platforms, and that it's an ISO, OASIS, and IEC standard. And we're all about getting people onto standards so that it's easier for them to come to or leave our services if they so choose. And so really our choice there with AMQP had to do with the fact that even though it can be a difficult protocol to understand, the flow control system in it is excellent. And it's a credit-based flow control system that gives the sender and the receiver a credit channel in which they can tell the other party that they can go faster or slower in their sending. And this is actually super sophisticated. Our clients do it all behind the scenes for you. It's nothing you have to really do much to know about, but it gives us an elegant way to both throttle senders when they're exceeding their purchase quotas, and to not just knock readers offline by shooting tons and tons of messages at them, because the protocol deep down actually is bidirectional. And even though you're a consumer, maybe you could say, connecting to receive events, there's actually a push on the channel happening from the service to your consumer. So this is kind of turning around the sort of request response, and you open a request and you get many responses pushed to you. And it can really cut down on latency times, and it's why we're really, really happy with it. And interestingly, HTTP 2 is promising to solve some of these problems, but we were really big on going with we've been using this protocol for 3 or 4 years now, and we're really big on going with a protocol that we already know, that is already a standard, and that we think will be increasingly used by more messaging providers as time goes on.
So you've talked about the differences between the Event Hub PaaS versus Kafka's software solution. Speaking more broadly, how can people evaluate the advantages and disadvantages of managed technology solutions versus the unmanaged raw software versions?
Yeah, this is a critical question that a lot of people will have to face. And the way I would kind of position this is that the easiest way to understand these is to understand the sort of workforce and environment you already have. So if you have the skill set necessary to run Kafka and to do it well, which is not always the easiest thing, then you're probably in a pretty good place with that. You can certainly get very low latency out of Kafka. You can do great things with it, but not everyone's going to have the resources necessary to run that kind of platform, especially in a 24-hour environment, in a really reliable way. So the question is really about trade-offs: is how much control do you want, which comes with the responsibility, versus how much sort of ease do you want. And so when you use a service, you're having to compromise on some things. So, for instance, a compromise for us is the fact that our latencies tend to be in the 50 to 100 millisecond range. Whereas if you're running not in a cloud environment at all, but on raw hardware, you could get much slower than that with actual disk access speeds being pretty low. But you're bringing with that other trade-offs like replication windows and corruption that can happen there, and also just pure cost of running. We as a PaaS service are probably less expensive than we should be, but we deliver what we think is a lot of value for very low cost compared to running on hardware, whether it's IaaS or in a private data center.
Since we're talking about these managed solutions, I would love to get some idea of how Event Hubs compare to products from other companies. Is it cool if we have like a discussion of kind of the comparison shopping?
Yeah, for sure. It's a discussion I like to have, and there's another service that I'm very fond of in many ways, made by people right here in the neighborhood. So I'm happy to talk about that.
So I assume you're talking about Amazon Kinesis.
Yes.
Okay, so how does Amazon Kinesis compare to Event Hubs?
So the two are pretty similar. They started off more different than they are now, and they still have some pretty distinct differences. The biggest differences are that Event Hubs was always designed to be a sub-second sort of system, and Kinesis at first was not. Although their latency's improved a lot since they've been public, but at first they had fairly high latency, and they've done a good job of sort of driving that down. Conceptually, they're fairly similar. They will call partitions as shards. They've made a few big design choices that we did not on purpose. And one is that for them, you actually pay for the shards you have. So you pay an hourly rate for every shard in your stream, and you can change that number of shards to scale up or scale down. In Event Hubs, we've chosen not to charge for partitions. And you use a different scale mechanism, which is just an hourly pay mechanism to purchase throughput, which is spread across all of your Event Hubs. So we don't allow the resharding, but we also don't make you reshard. So there's no cost reason to have to reshard. And as nice as the concept kind of sounds at first for resharding, it becomes quite difficult, especially if you have order requirements, which we kind of addressed earlier. Because now you've changed where something is living over time in a durable buffer that's going to be around for a while. So if you rewind that buffer, or you have readers who are behind reading from one partition or shard, now all of a sudden their data will be in a different partition or shard, and so they'll have to do a jump between those two. So Kinesis does give you this ability to change your shards. It's manual. You have to reshard manually by splitting and merging shards. And then there's another sort of difference too, in that ours, using this AMQP model rather than the HTTP model of Kinesis, we've always been sort of biased to very many concurrent requests for our platform period, because we're using this binary protocol that lets us go real fast with a lot of stuff. And the Kinesis model is more towards sort of put records. So putting a batch and you get a settlement back that tells you where or how each message in that batch fared. Whereas for us, we do batching as well, but it's more of an atomic operation. And we do a better job of supporting multiple concurrent requests, which for us can be up to like 1 million concurrent requests. So that's it's something we pushed pretty hard on is to favor concurrency over sort of batching.
And Google has a product called Cloud PubSub. Is this analogous to Event Hubs?
PubSub's a pretty cool product too. Actually, I've played around with them a lot, and it's interesting because it's kind of like Event Hubs and kind of like our service bus messaging platform. It's unique, and I actually think this is really unique because all three of the big cloud players have chosen a slightly different way to tackle this sort of challenge. And so we don't really have a situation where we're flat out in head-to-head competition with each other, and we're all trying kind of different things. And PubSub is certainly similar in some ways and different in others. And the ways it's really different is that it allows you to have many, many, many subscribers, whereas our model is less about having a lot of subscribers and more about having a whole lot of throughput. So we think we have a higher throughput model, but a lower subscriber density model, if that makes sense. And then they also have some other cool features in there, like a HTTP push capability out of the subscribers, which is also pretty interesting because you can kind of push to App Engine components further downstream. So yeah, we've all kind of taken a different approach, and they're all very useful in their own ways. And I think it's actually kind of cool to see this much innovation in the space.
Yeah, me too. I think this is this really interesting discussion. I think many times the lens that people look at it through is a little more of a hyper-competitive old world lens than a more modern context. Because like the more modern context is that the idea of, quote, cloud computing or whatever you want to call it, platform as a service, even infrastructure as a service, the demand, the value offering of this set of technologies is so gigantic and so multifaceted that there really is room for such a multiplicity of different providers. And I think one of the things you kind of touched on is like this. It depends on application requirements. So, what are the types of application requirements that the Azure stack is trying to optimize for?
Well, that's a really good question. The place we're still targeting, which is kind of a traditional area for Microsoft, is really in sort of the enterprise space, or the space where reliability and durability are probably the biggest concerns. And scale, sure, is a great concern too, but a lot of our sort of sweet spot is across all of our services is really when you're looking for something that's secure and durable, and has a lot of sort of ability to work over time and be supported over time. So that is really kind of our approach. We're trying to make the cloud easier to use. That's why we're pushing so hard into PaaS and SaaS services and not just IaaS services. And I think that's kind of the place we've sort of set our sights and sort of the way we're really kind of leading and innovating in. And again, like you said, it's not that people are going to say that it's just one cloud provider. It's picking the right tool for their needs. And some companies will have different needs than we can provide. But we think more in the sort of enterprise space, or even to a lot of startups, because the cloud brings a lot of different models with it, that we're probably better positioned in that sort of space, especially in the context of total cost of ownership, which is something with our PaaS and SaaS focus. We're really trying to drive down TCO on any technology solution through our cloud platform, rather than just having a sort of a commoditized compute platform or IaaS platform that you can just run what you've been running, just for less money and on more scale.
What does that term mean? Total cost of ownership?
Yes. So this is a good one. I come from consulting originally, so I always have these things on my mind. And not Microsoft consulting, outside consulting. So that would be the cost of a solution over its whole lifetime. So that could, there are costs we all think about, like building something in the cloud. We all think about usage costs because they're deceptively, we think they're easily calculated, although they're not always. That is really a combination of those things over time. The cost it takes you to actually build something, the cost it takes you for running the platform and also maintaining the platform. So it's really kind of the whole all-in cost of running your service over time.
So my impression is that the way to actually compare these technologies is not by just looking at the PubSub streaming service, but rather the entire stack around it. So, whatever other technologies in Azure complement the PubSub streaming service. So what are some of the other technologies in the Azure stack that have synergies with Event Hub?
One of the easiest to get started with is actually Stream Analytics. This is a great service we've had out for a while now. Very close colleagues of mine that I work with regularly. They have a stream processing based service, which is letting you run SQL-like queries on time windows of a stream. So it actually enables you to do very complex things that are very hard to do in code, very, very quickly and easily. It's also another PaaS service, so you get the added benefit of not having to run a platform, and it integrates directly to Event Hubs, both as a reader, so a consumer of Event Hubs, and as a publisher. So you can actually assemble pipelines of processing that happen through different stages of Event Hubs and other technologies. And a really cool part about that is that they actually have the ability to write to not just Event Hubs, but also to our queuing system, to blob storage, to SQL Azure, and Power BI. So a lot of other, actually there are like 12 others that I didn't mention, but a lot of other sort of downstream components where you can put the output of your calculations or your processing on a stream to more use. So for instance, Event Hub itself doesn't actually do any processing or reformatting or time window based calculations, and there's a way to very quickly and easily put those capabilities in. We also integrate pretty well with HD Insight. HD Insight actually ships with a Storm spout that can read from Event Hubs. So you can use Storm on HD Insight very easily with Event Hubs. They actually work quite well together. And those are kind of our two biggest sort of ways to go. And then finally, the last one would be our platform for Service Fabric. And Service Fabric is a very cool, very powerful distributed computing platform. And I guess those three would be listed then in the scale of lowest bar to entry, but maybe with some limitations, to the Service Fabric part being the absolute most raw power to do pretty much anything. But with a lot more sort of coding work you have to do yourself to get it done. So we have a pretty good continuum that addresses sort of the code list to the pure code distributed computing, and kind of everything in between. So we have a pretty good ecosystem there.
And looking at the different ecosystems, Azure and AWS and Google, do you see these mapping to specific consumer verticals? I mean, I know you mentioned Azure going more after enterprise. How do you see the space evolving over time in terms of the customers that these different services want to appease?
Yeah, that's a very good question. I think for Azure, our focus is very much on enterprise and IoT, pieces like that. And over time, we'll probably branch out from there. I could definitely see a bigger space in sort of Um, I guess cloud-based social and cloud-based value-added services that are outside of Microsoft but running in the Azure ecosystem. Um, Google, I don't see as maybe being as developed on the tools or integrated services standpoint, and Amazon, I'd say, is doing a fairly good job too. I think that they'll probably compete a little bit more for the market we're going after. They're trying to ramp up their PaaS offerings as well. Right now, most of their offering is really more targeted towards developers or IT admins, and really you kind of need a mix of the two. Whereas we're really more targeted towards the DevOps audience, where you don't have separate IT admin and developer teams. You have one team moving very quickly, and needing a broad set of tools to be able to meet their objectives.
I see a few different arguments when I read about this stuff in terms of where we're going with portability. So, like, I think I think it's an interesting question. Like, how commodified will these services get? How easy will it be to move from one cloud service to another to port your infrastructure? There's this idea of maybe using Docker to magically containerize everything in your infrastructure and throw it in a suitcase and move to a different cloud service provider. What do you think is in store for the future in terms of like how commodified these services will be and how intense the lock-in will be?
Yeah, that's a great question. The lock-in one is kind of very interesting. It's why we've seen a lot of people take this sort of lowest common denominator approach to their cloud solutions, because they want this ability to move between cloud providers. And there's some value to that for sure, to that concept. But then there's the bigger question of, are you actually going to make this move? And is it really going to be as easy as you think? Because when you start off and you're just thinking, well, okay, I have infrastructure running. Okay, you can put infrastructure anywhere. But as you get especially to a more sort of agile, continuous delivery model, you're building a lot of stuff to tie this infrastructure and deployment together. And everything you're building is making it kind of harder and harder to move. So you've kind of given up all of the free stuff you can get from a single vendor sort of proposition, and all three of the vendors offer things that are really targeted towards their platforms. But you might not be getting as much as you think in return. It might not be as easy to switch. From our standpoint, we're trying to build services based on a standard protocol, so it's as easy as possible for people to join and leave our messaging platform. And we understand, actually, we have a lot of customers who run parts of their cloud workload on other cloud platforms, and that's totally fine, and on other operating systems within our cloud platform. So we're really not trying to be a Windows-focused service. We're actually working very heavily on clients for Linux, and both through Node and Java right now, because we really see ourselves, rather than sort of a specialized, like a platform specific, Windows specific offering, to really be a sort of, like you said, almost a commoditized service that's easier to plug and play. And I think if you look at our Event Hubs and Kinesis, moving between them is certainly possible. It is not necessarily going to be the easiest thing to do, but our hope is, with the AMQP part, that over time more and more messaging vendors will be in that space. We have quite a few already. Red Hat is using AMQP. So over time, our objective is to make it as painless for the messaging components for people to either come to or leave our platform. We really think that will push us to just provide the best service possible. We don't feel like we need to use vendor lock-in to get business this way. And we have some momentum behind that, because it's actually being pushed at the federal government level in the U.S. for messaging platforms used by the federal government to use the AMQP protocol. So we're kind of trying to stay on board with the whole industry there, and we're trying to take a more active role in it, and trying to really kind of move away from this idea of this is a Microsoft messaging platform to being this is just a messaging platform, and you can pick the right messaging platform for your needs, regardless of the rest of the stack.
Sounds like you see a future of polyglot cloud, perhaps?
I think we're already there to a large extent. I think the way that's really started that people haven't realized is it started with SaaS. And I think it's bleeding now more and more into PaaS type services. I think something like Dropbox was a great example, where you're really, you get some benefits by going with one cloud provider, but you're probably never going to end up with absolutely only one. Tons of people use Salesforce. Doesn't mean they shouldn't use Azure or Amazon services with that. That's just, reality.
What's the future of Event Hubs?
We have some fun stuff we're looking at for Event Hubs. We're looking at a deeper integration into the Azure platform itself. Actually, some integration with outside services and software makers, which will be pretty interesting, I think, as well. And then we're also looking at what other sorts of problems are people trying to solve related to telemetry processing. We know that we've spent a lot of time and energy focusing on this whole sub-second, very fast data problem, and we've met it very well for our core big customers. But we think there's actually opportunity to meet some maybe not so fast data challenges for other customers. So I would say sort of integration is our, branching out into tie-ins is our one future path that we're already taking. And then sort of branching out into other service offerings that are complementary would be kind of the other way we'd look at it.
Yeah, I love the bright future of IoT, except I don't have a sense of how close we are to the realities of that bright future. Like, I feel like we're asymptoting towards it, and I just don't know how close we are. What's your sense of how close we are to, like, the brilliant future when our refrigerator is talking to our phone, talking to our car, and whatnot?
I think it'll be sooner than people realize. And even just within those, I think the innovation needs to happen within those industries themselves. So it's interesting to look at something like Azure as an IoT platform. Microsoft's not really trying to run the car business and the phone business and the television business. We're really trying to put a platform in place that people in those industries can run their platforms on. And that's the sort of the piece that needs to happen. Building a scalable, highly available platform is very challenging. And if we, and I'd say the same for Amazon too, if we can do a little bit to alleviate the cost and pain of that, then we'll actually rapidly increase the speed at which innovation happens on top of that platform. And that is what's happening now. And I think that innovation's pretty close to taking off. And once it happens, it'll be a lot faster than we expect. Because if we look at just sort of the progression of technology, a long time in the past, you had to actually figure out how you were going to store data and write storage code on a server a long time ago. We've gotten past that sort of challenge. We just keep sort of abstracting up higher and higher levels, and we're getting closer and closer to the real value delivery here. Because unless you're on the Azure storage team, I don't think you really care about how storage works. You just expect it to work. And if you're doing something like providing smart meters or in-home connected experiences, you really don't care about that at all. It has zero value for your customers and for your business. So the higher we can abstract these pieces, the faster that innovation will happen.
And how high can we get that abstraction? Like, do you think people are going to be able to just point and click and develop their apps entirely from a web browser? Like, will I be able to wire together an entire IoT infrastructure just by clicking on things in a web browser?
I think eventually, yeah.
Interesting. Is that a goal of Azure?
That I can't speak to, but I actually think it could be even easier than that. I think at some point we'll get to, if you look at the way Bluetooth devices interact with each other, and that's been a very, very long, painful process to get there, but it's already pretty remarkable what they do. And when we think about what 20 years of experience on that technology can teach us, we can get to much more simple sort of self-assembly, self-configuration type experiences that'll be really, really expressive and really customizable, and really more software configured than hardware configured. So I think we're getting pretty close.
Yeah, and there's this holy grail. You think about enterprise people. If I think about like an insurance company or a some factory that's producing canned goods, there's plenty of people at these types of organizations that are technologically inclined, but they are not programmers. So they would be able to read some documentation and maybe wire some stuff together from a web interface, but not necessarily be able to go into an IDE and write code to hack together a full stack app. And why should they have to?
Absolutely. And this is the challenge, is that those people in those industries, they are the ones who will have the ideas that drive innovation.
Yeah.
So until we make it easy for them to do that, they have to make very risky, big bets, that don't often pan out. Mm-hmm. And it's very hard to get to. If you look at a great innovation in the insurance space has been the plug-in dongle for your car. That's actually very simple technology, and it's totally makes sense in the insurance space. And all of the technology used to do it has existed for almost 20 years. But it took until very recently for that to get moving. And now every major insurance company offers that ability to change your rates based on your actual driving behavior.
Yeah. See, this is why I like doing these shows about Microsoft, because it's so, not to be critical, but like it was so easy to be cynical about Azure before I kind of really understood what was going on. I was just like, okay, it's yet another cloud service. But then I just kind of started looking into it more and started understanding that just how big the ecosystem is, and this enterprise, non-programmer to programmer enabling. It's really interesting. It's really optimistic future, and I like it. So, well, Dan, thanks for coming on to Software Engineering Daily. It's been really interesting talking to you about Event Hubs and the rest of the Azure platform.
Thank you very much.